So, Unit 9 is all about what we call correlation, which is like when something affects something else or they have to do with each other. So it's a little bit more statistics, and then a new concept called residuals. You guys, let's say it together. Residuals. That's how it's spelled. Residuals. We're not going to get there with residuals just yet. So today we're going to be looking at what we call least squares regression. So let's write a definition first. What is linear regression? That's kind of a new concept for us. Linear regression is the relationship between two variables, so just two variables we're going to be dealing with, in a data set by producing what we call a line of best fit. How many of you have heard of line of best fit before? Nobody? Not in science? Okay, a line of best fit is when we have a whole bunch of data that's all kind of scattered around and it doesn't make a line. But we can create what we call a line of best fit that is the best fit through the set of data points to best represent our line. And that's what we're going to be doing today. Okay, so we're going to go straight into example. Example 1, I'm going to have you write down this table, and this table shows the percent of all recorded music sales that came from music stores in the years 1988, it should be 1998, through 2004. So on our table we have 1998 was 50.8%, 1999 was 44.5%, 2000, 42.4%, 2001, 39.7%, 2002, 36.8%, 2003, 33.2%, and 2004, 32.5%. What do you guys notice, just as you're writing down the graph, what do you notice about the data as the years go on? It's descending, right? It's getting lower. Now this is music sales from music stores. Any ideas as to why in 1998 music sales were so much higher than they were in 2004? iTunes, right? You don't have to go to a music store to buy music anymore. You don't have to buy the CDs. You can buy them on your computer. Okay, so this actually is happening. So we're going to be looking at what it looks like on a graph. Okay, so the first thing that we're going to do in order to plot these, we need to represent our data as ordered pairs. So that's part A. The one thing I want you guys to make sure that you are aware of, when we are looking at sets of data, especially sets of data that have to do in years, we don't want to represent, say, our years as 1998. We always start where we're counting at year 0. So 1998, because no time has passed, because we just started counting that year, is going to have be the same as a coordinate 0. So what would 1991 be? Or I'm sorry, 1999 would be a 1 because 1 year has passed. Does that make sense? So it's the first 1 year since we started counting. So 2000 is going to be 2. 2001 is going to be year 3. 2002 is going to be year 4. 2003 is going to be year 5, and 2004 is going to be year 6. So we look at it in time in terms of how many years have passed, not what year it is. Does that make sense? So to represent the data as an ordered pair in year 0, no time has passed yet. That's going to be our x coordinate, and what's our y coordinate going to be? 50.8. So in your groups, I want you guys to represent the rest of the data. So the next one is going to be 1, 44.5, and then finish it for me all the way to year 6. Okay, so here's what your ordered pair should have been. You should have had 2, 42.4, 3, 39.7, 4, 36.8, 5, 33.2, and 6, 32.5. Thumbs up if you got all of that. Not too bad, right? Yet? Right? Okay, so here's what we're going to do. We are going to graph. So I want you to write part B is to construct a scatter plot of the data, and then here's where I'm going to have you glue in the instructions. So I have them in mind, but you are going to glue in the instructions. So part B, we're going to construct a scatter plot of the data, and then here's your instructions for doing that on the graphing calculator.
Why are you comparing it to me? I'm the one that you
All right, so we are actually going to graph this data, but instead, because all of our y values are like 50.8, 44.5, we're going to graph on the graphing calculator. So here's what we are going to do. Get out your graphing calculator. Some of you might have to share. Let me turn off the light. Does that help? Okay, so the first thing we're going to do is we're going to go back to our list. You guys remember our list? So you're going to press the Stat button, and then press Enter, because we want to edit our list. And there's probably going to be data in those lists. So remember how to clear it. You go up and highlight the list, so like where it says L2, you're going to press Clear, and then Enter to clear that whole list. And you're going to do the same thing for the next one. So we're going to go up, go over so that now L1 is highlighted, clear, and then press Enter to clear the whole thing. So now all of your lists should be totally clear, yes? Okay. So the next thing we're going to do is we are going to enter our data. So to enter our data, L1 is going to be our X values. So our X values were 0, 1, 2, 3, 4, 5, and 6, right? And then in L2, we're going to list the corresponding Y values in the same order. So that's 50.8, 44.5, 42.4, 39.7, 36.8, 33.2, and 32.5. Okay, so make sure all of those are entered. So we should have, next to every independent quantity, 0 through 6, we should have a dependent quantity right next to it, yes? Okay, so then we're going to press the second button again, and press Stat again, or I'm sorry, Stat Plot. So where is Stat Plot? Let's go back to hit Stat and hit Edit. And then we need to hit Stat Plot, which is, does anybody see it? So you're going to hit second, and then does everybody see at the top where it says Y equals? Stat Plot is up at the very top where it says Y equals, and then in yellow it says Stat Plot. So you're going to press second and then Stat Plot, and press Enter. It's going to see a whole bunch of weird stuff. And then press second, Stat Plot again. And then Enter. The cursor should be on the word on. Press Enter to turn on Plot 1. Okay, so we're turning off all plots first. So we're going to turn everything off. So you go second to Stat Plot, press 4. It should say Plots Off. When you press Enter, it should say Done, meaning that all the plots have been turned off so far. Okay, so this means that we turn all plots off, and then we're going to go through the process again to just turn on the one that we want. So go second, Stat Plot, press Enter so that we're accessing information about Plot 1, and the cursor should be on the word On. So press Enter so that we turn Plot 1 on. Okay. Move your arrow keys down so that you are highlighting where it says X list. So there should be the flashing cursor right here on X list. And set L1 values as your X values. So everybody should say L1 where it says X list, right? Okay. No? Yours does not? And then we're going to do the same thing to make sure our Y list says L2. So if it doesn't, highlight it and then press second, and L2 is right above the number 2, okay? So we should have L2 as our Y list, and then we're going to press Window to set the bounds of our graph. So everybody see up at the very, very top, all these buttons, there's a window. So press Window to set the bounds of our graph. So our X minimum, let's make it -10, and our maximum is +10. Okay, so that should already be that way, right? That means that the smallest x value on our graph is going to be negative 10. Actually, let's make it negative 1. Okay, so make it negative 1, so then it looks like what we're going to draw. Our x maximum, let's make it 10 because our biggest x goes up to 6.
Wait, how do you make it negative?
The negative is this one right down here in the very corner.
Oh.
Okay, so what we're doing is we're telling the graph where we want to start with the x values and where we want to end with the x values. And then let's look at our y. So scroll down to where it says y min. And our smallest y value is actually, what is it? Our smallest y value is 32.5. So let's start our y min at 20. Okay, and let's do our y max at, how about 65? But our scale, so if you go down, our y min is going to be 20. Our y max is going to be 65. And then right underneath it, it says YSC1. That means y scale. So that means what each dot is, or what each line is going to represent. And let's do it by 5. So change your y scale to 5. Our x scale should say 1. Okay? So our x min is negative 1. Our x max is 10. Our x scale is 1. Our y min is 20. Our y max is 65, but our y scale is going to be 5. So your window should look like this. Okay? Now we're actually going to let it graph. So you are going to press graph. Okay. Okay, ignore those lines. I don't know why those lines are showing them. Okay, so we should have little plots of data that look like this, right? So what it did was it plotted our x and our y values for us. So what I want you guys to do is we're going to copy that scatter plot, and it's called a scatter plot because it's just little dots scattered all around. We are going to copy it and graph it in our notes, okay? So I'm going to put my calculator right next to my graph. So draw a graph. And my graph already has the scale that we used. So on the x, we start at 0, and we're going to go to 10, and there's just one line, means each number. And then our y-axis starts at 20, and it goes every 5 all the way up to 65. Okay, so draw your graph, and then we'll plot the data. Okay, guys, before we can start plotting, we need to actually label our axes. What does the x-axis represent? 0, 1, 2, all the way to 10?
Years.
The years. So this is going to be years. But it's not years, right? I mean, it's not year 0, year 1, year 2. It's the years since 1998. So that 0 means 0 years had passed since 1998, so we hadn't started recording time yet. The next one year had passed since 1998, so that gives us 1991. 2 years had passed, so that's 2000, right? 3 years had passed, so 2001. Does that make sense? So it's the years that have passed since 1998. And then what is our y-axis? Percent of total sales. So we can abbreviate that a little bit, but along the y-axis, I am going to write percent of total sales. Or let's do total, total sales. Okay. So we need to label our x and y axis first. And now let's use our scatter plot to, there we go, to graph it. So our first point is at 0, and it goes up 1, 2, 3, 4, 5, 6, which should be at about 50.8, right? That's what our value was. So we're going to start at 0, and the next one is 50.8. So it's going to be actually really, really close to 50 on the y-axis. That's this point right here. The next one is at 1, and that one is almost exactly on the line at 45. So let's put it just a little bit under because our data point was 44.5. The next one was 2, and that one is at 42.4. So that one is almost exactly in between 40 and 45. Oops. So that's this one right here. And it looks right in the middle. 3 is at 39.7, so that's almost exactly 40. 4 was 36.8, so that's going to be just above the 35 mark. 5 is 33.2, so that's like right in between 30 and 35. And 6 is at 32.5, so that's going to be like just under our next one. Okay, so your plot should look something like that, which should match what was on your graphing calculator. And you aren't going to be asked every single time to graph what's on the graphing calculator. I'm showing you so that you know how, so then you can look at the graph without having to plot it every single time, okay? So, do you guys notice the pattern, part C? It's decreasing. What shape kind of does this make?
Linear.
A linear. It looks like a linear graph. Is it exactly linear? No, but it's pretty close, right? So I would say that the graph has a linear pattern. And at this point, we don't really, it doesn't really matter if it's increasing or decreasing. I just want to know, does it look like a linear function? Does it look like a quadratic function? Does it look like an exponential? So what kind of shape does it have? So this one has a linear pattern. So part D, we're going to calculate the linear regression equation for the data, and that's going to be the second set of instructions. So I want you to tape or glue that second set of instructions into your notes right now. So what this is going to do, this set of instructions, we're going to calculate the linear regression equation. Remember, linear regression is finding the line of best fit. So because our scatter plot shows that this is a linear pattern, but it's not exactly aligned, we can use the graphing calculator to find the best line that represents this set of data. Does that make sense? So it's going to create an equation for us that is the best line to represent this set of data. Okay? So cut out your instructions, paste them into your notes, and we're going to do it. Okay, guys, so we're going to use the graphing calculators to actually calculate the equation that best represents this set of data. So it's going to be a linear equation, and if we were to graph it, it wouldn't go through all the sets of data, but it would be really close to all the points. So let's do that. So turn your graphing calculators back on. If you had one that wasn't working, just share with somebody else. Okay, so you're going to, first thing we have to do is make sure that the diagnostics are turned on. So you're going to press second, and then we're going to look and see where it says catalog. So in yellow, we should have a place that says catalog. Do you see it right here on the 0? So you're going to press second and then press 0, and it's going to take us to the catalog. Okay? Okay, now we're going to do a little bit of scrolling. So all of this is in alphabetical order. So we're going to scroll down to the D's. So scroll down, 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 down to the D's, and we are looking for the one that says diagnostics on. Okay, so there's a diagnostic off. Highlight the one that says diagnostic on, and then press enter. So now we should have on the home screen a message that says diagnostic on, and then press enter again, and it should say done. So that means that we turned the diagnostics on. Okay. I don't know really what that means. This is what it's called in calculator. Okay, so you should have this. Okay, so then we're going to press stat, and use the right arrow to highlight where it says calc. So we're going to be calculating some things. And then if you guys look at number 4 says linear regression AX plus B. So press 4, and it should say lin regress or lin reg AX plus B on your home screen. And then we're going to want to turn everything on. So where it said linear regression, it should say that screen. You're going to press enter, and it should give you this. Okay, does everybody have this screen? Yes. So it says y equals ax plus b, and then it gives you an a, a b, an r squared, and an r. Okay, our linear regression equation is in the form y equals ax plus b, and then it gives you your a and your b. So we're going to plug in those a and b values into the equation, okay? So that is going to be y equals, so just underneath where you wrote or pasted the instructions, it's going to be y equals, write in ax plus b so that you have it written down, that we know what we started with and how we got that. So in this case, a was, and then underneath write a equals for me, just so in your notes you know where you got these values. Let's round to the nearest hundredths place. So that's negative 2.97, and b is 48 point what? 89. Okay. So to find our equation, you are going to plug in the a and the b into the y equals ax plus b. So our linear regression equation is y equals negative 2.97x plus 48.89. Box that. Now, I'm going to show you guys something. You do not have to do this on your graphing calculator, but I want to show you kind of what it is we're doing. So I'm going to go back to my graph, and I'm actually going to plot that line. So negative 2.97x plus 48.89. So I just want to show you guys what's going on here. Does that look like a pretty that we plotted? So here's what it is that we did. These are all of our scatter plot individual points of data. Does anybody remember what kind of graph that's called? It's a scatter plot, but it's not continuous, it's discrete. So this is our discrete data, but I want to make a continuous line that represents that discrete data. And my calculator told me that it was negative 2.97x plus 48.89. which is that line that I just graphed. It's pretty close, right? It's not going through all of the data points, but it's pretty close to all of them. So that line is what we call the linear regression equation for that set of data, okay? So now we're going to use that equation to actually make some predictions, and that's called interpolation. So interpolation is when we use the linear regression to make predictions within the data set. So now we have the linear regression equation, and we're going to make predictions about how our data is going to react in the future based on that. So assuming that our slope stays constant, we're going to look at what the data is going to do in the future that may not have happened yet. Okay? So what we're going to do is I want to use the equation to predict the total music sales that came from music stores in the year 2000. And we're going to compare it to what actually happened. So 2000 is our X, right? But 2000 is how many years after 1998? 2. So we're going to plug in 2 for X. So underneath I want you to write X equals 2. So that's going to be Y equals negative 2.97x plus 48.89, and we're going to plug in x equals 2. So that's negative 2.97 times 2 plus 48.89. plug it into our calculator, and negative 2.97 times 2 gives us y equals negative 5.94 plus 48.89. And then let's add 48.89, and we get y equals 42.95. So how does that compare to the actual percentage? It's about 43%. Hold on. We actually have the exact amount for the year 2000. What did it come out to? It actually was 42.4. We calculated it to be 42.95. Were we close? Yeah, we were really close.